I've always known my husband was pretty smart as shit, but in recent years, I've also noticed he has a knack for explaining stuff so that other people, like myself, can understand. And I'm no dummy, but I'm also not a scientist. But what I can usually understand are Levi's explanations when he explains them in layman's terms, thus the name of our series. So today we're tackling quantum mechanics, spooky action at a distance, and quantum tunneling. Sounds boring as shit, but it's actually pretty fucking cool when he's explained it to me. So listen in. And quickly, our disclaimer, these are solely Levi's thoughts, opinions, etc. based on nothing but resources he has attained on his own free will. We will avoid hot topics and politics and rather focus on the hows and whys. So, Levi, take it away. Talk to us.
Which one do you want to start with?
I don't know. First, turn down the music. You got that?
I did. I turned it down.
Good. Perfect. I would say the spooky shit because that sounds spooky.
So, I keep going back to Einstein, but he's like was pretty good at what he did.
You're in love with him.
I am. He, so way back in the early 1900s, when he was working on all of his theories and doing all this stuff, he came across mathematically, and I don't understand the math. It's way beyond like my sense. But he figured out that, and he couldn't explain it, if you were to take two linked particles, in which we can do, we've replicated it. If you took two of them and you spread them apart, mathematically he proved that if you influence one, the other one would be influenced like instantaneously.
Oh.
Which,
what do you mean by influenced?
like if I won't bore you, but like you have spin. So if one is spinning up, if you change the spin, the other one's spin would instantly change.
Oh.
And if you think about instant, we think like, Wi-Fi is instant, but it's not. It moves at the speed of light, right? So
Wi-Fi moves at the speed of light?
well, the signal moves at the speed of light. Your computer may not move at the speed of light, but the signal moving across from, even your cell phone from tower to tower, that microwave moves at the speed of light. So he found out that it actually moves faster than the speed of light. And according to his theory of relativity, nothing should move faster than the speed of light. But back then in the 1900s, they couldn't test this, right? So he called it spooky action because he couldn't explain it. He did not believe his own theorem. He's like, no, I screwed something up, like it's not right. And it turns out he was actually right. So I think 20 years ago is when they first did it, but they've actually like got it even fine-tuned. So they found they used particular types of photons that are paired. And if you take one photon and they match, so that
What are photons?
that's what makes light. Moves in a wave, it's light. It's everything you see. They took these two photons that are twins, so everything you do, they're clones of each other. And if you separate them, and they separate them like thousands of miles, like they put one in New York, and I think they put one like in Italy or something like that, like literally on the other side of the world. And the minute they changed the spin on one, the one in Italy instantaneously moved.
That is bizarre.
So if you think about it, like it shouldn't do that, right? It should take light. Everything moves at the speed of light. So it should take the speed of light
to get
so
there.
this should be like, it'd be fractions of a second. I mean, light can go around the earth 8 times a second, right? So it's super fast.
Jesus.
But you can still measure the differences. And they found that like it was instant. So it shows two things. It shows that one, things can actually move faster than the speed of light. And two, our theory of, light being the ultimate measuring stick maybe isn't necessarily true. So it's kind of like there's a lot of theories around it now that are even super far-fetched, like whatever is moving in between the two, the message, right? The message of when you move this one moves. That message signal, the theory is it actually jumps to a different dimension and then comes back into ours. And in that dimension, it experiences time, but in ours, it doesn't. Really weird, really far-fetched stuff. But quantum mechanics are like super weird. What was
So
the
how does that apply to like everyday life? Yeah, and then we'll get on to quantum tunneling.
It has no reference to anything that you would ever experience in any day of your life.
So
It's just
it does not matter.
It's just a totally weird quirk in quantum mechanics. It has no explanation. You would never notice it on anything you ever do your entire life.
It does not affect anything.
Nope, in any way.
So far
Well,
as you
actually, that's
know.
not true.
Oh?
That's not true. So they're working on quantum encryption, which
Okay.
means if, because, you know, hackers always try to hack signals,
Yeah.
hack messages.
Yeah.
So the idea is if you could take those same particles and link them, you could share a message in between each other, and it would be quantumly encrypted. Because the thing with quantum mechanics is if you, it's really strange. If you leave the signal alone, it'll go from A to B instantaneously. If you try to measure it, you can measure it, but it instantly stops. So quantum mechanics are really strange. So no one could actually hack a quantum encrypted signal, because the minute you read the signal, you'd kill the signal and you couldn't get the full signal. So you'd only get a piece of a message and you'd lose the entire message. It would also tell the other party that somebody hacked it because the signal never came in.
Right. Wow.
But we don't necessarily have that yet that we know. But the government does. They got
Yeah.
new shit. But
Okay, so the other thing is quantum tunneling.
yeah, that's a weird one.
Okay.
So quantum tunneling is, it'd be like you being over at the TV 1 second, and then
Our kids are watching shows
and then
right
like
now.
a split second later you would appear right where you're sitting right now. So
What?
you basically just move back and forth. So if you go on a quantum level,
Within seconds, not even.
not even that, like instantaneous.
Nanoseconds.
So they found that on the quantum level, which is subatomic, things move around like instantaneously. Things appear and disappear for like no reason. And they had this thing called quantum tunneling where they put in a barrier and not molecules, I should say. I don't even call them atoms because it's even smaller than atom, but they'll disappear on one side and they'll reappear on the other. So things can move around all the time. And if you look at the basis of quantum mechanics, which I am by no means an expert, but it's all basically the entire theory is based on the probability of finding a particular atom or subatomic particle in an area at a given time. So it's all stats, right? So things can move around all the time. Like the vacuum, the space they find actually isn't a vacuum. There's millions and trillions it's a huge number where they're literally just appearing and disappearing, and no one can explain it, right? So no one knows why these things appear and why they disappear. So it's still a mystery. They've never solved it. We haven't solved quantum mechanics. But again, that'll never apply to anything you ever do to any part of your life.
Right. So what you're saying is like the science that we all learn in maybe college level, I would say that probably is irrelevant and completely useless.
Not true. Not true. A lot of the science you learn in college is still relevant and still true. Just
not quantum.
Just what I'm talking about right now, for most people on a given day, doesn't necessarily matter. For quantum physicists, this is really, really cool stuff. For people on the theoretical end of things, it's really cool stuff. But for you and I, it doesn't change anything you're doing on a day-to-day basis.
That's awesome. Okay, well, thank you for enlightening us on quantum mechanics. And so we will be back soon. Thanks, Levi.
Bye.